So special. Okay, so you can write it either of those two ways. When you have numbers in here, sometimes it's advantageous because you could have like 6 to the 8th power under here. And if you wrote the 8th power over here, it just makes it easier in the end. Because you could end up with 2 under here once you simplify. And then if you raise that to the 8th power, it's doable. 264. Okay. So when n is even, the domain is restricted to positive values. Why? So if we have like the square root of, so it would be like the second root. Square root and second root are the same thing. Why can I not have a negative right here? What happens? Huh? If we do square root of like -8, what happens? What happens when you do negative square roots? You get what kind of other letter? Imaginary, right? Turns out to be imaginary, so we won't have any negative x values when the number in the elbow is even, okay? So I would highlight that so you remember that. That'd be a smart thing to highlight, okay? Get your calculator out. We're going to put in x to the 1/4 and the y equals of your calculadora. I don't think I have any in there. I don't have any graphings. People have stolen them all.
Oh, okay.
That's why. Yeah. High school kids are thieves. It is true. Okay. You put in x to the 1/4, hit graph. Please be quiet. X to the 1/4, hit graph. It should look like that. If your window's messed up, hit zoom, top, middle, 6 to get back to a regular window. Zoom 6 to a regular window, top, middle, and then just hit the number 6, and it'll fix your window if it's weird. We good? Anybody need help? For your school calculator, you get this is x to the 4th power divided by
Probably the same thing.
Yep. Yeah. Okay, hit zoom 6. Yep. There you go. Your window is just zoomed in. That's why it was weird. You need help? See? Different than first period, right? Nobody needed help with this? So because you guys have these parentheses. Right? Because what it would do for you guys without parentheses, x to the 1st power divided by 4. So it's graphing x over 4. Instead of x to the 1/4. It's going to be they're a little more ambitious as us too. It's like the second versus 6th period in I would say we get the second and then and then ramp is good, hit 1, and then hit 2. So if that happens, you can just do that. You'll need parentheses with the 1/4. So you got to put 1/4 in parentheses, otherwise it'll be not. All right, anyone else need help? Are we good on that part? Okay, so remember how last lesson we were plugging in some x values to figure out where the graph was? We're going to use the table now to figure out where the graph is. So we're going to go second graph and see how I have error messages, right? Because what would be in the elbow of the radical? What number? Look at the problem. What number would be in the radical? No. 4, right? 4 would be in the radical. That's an even number. That's why we won't have any negative x values in this graph, right? It makes sense because if you look at the graph, there's nothing over on that negative side, right? So that's why that makes sense. So we go second graph, and we're going to grab some. So we've got 0, 0, 1, 1, and then this graph goes to 8 on the x-axis. So we're going to do 8, 1.6-ish. So we're going to graph that over here. So we've got 0, 0, make it out. 0, 0, 1, 1, and then I already forgot the other point. 8, 1.7 basically. So 8, 1.7. And then draw your graph. So as far as how we're going to grade you on a test, right, if your graph on the right side here goes above 2, we'll take points off. Because I want you to be able to check that table and know where the graph is on the grid, right? So you can't screw up that graph. I'm not going to be fully psychotic about it, but if you draw it, you just kind of randomly draw it like that, hell yeah, I'll take points off, right? If you go up to 3, I'll take points off. So just pay attention to that. Yeah. Just because the end of the graph is 8, so that's why I chose 8. Okay, simple as that. Yeah, nothing crazy. Okay, we good? Anybody need help on that? What is the domain of this function? Where do the x values start? 0, and where do they go to? Infinity. So is it squared off or not at 0? Yes, it is squared off. Bracket at 0 to infinity. Okay, how about y values? Where do the y values start? They also start at 0, squared off. And where do they go to? So that's a great, like I was hoping I would hear that, infinity and 2. So now we got to discover, does it go to infinity or does it stop at 2? So here's, my calculator is nice because I can just scroll. So if I'm at 11, so I'm just going to scroll way the hell down. So I'm at 1100 and change and it goes to 5. So will it keep going up? Yeah, just very slowly, but it will keep going up. So that's why it's infinity right there. And that app is free, by the way. So it's really nice to display on here. What is my x and y intercept? 0, 0, 0, 0. Which is this function doing, increasing or decreasing? Increasing. Is it decreasing? No. So let's write no for decreasing. How is it increasing? So intervals is x values, because people are getting confused by that. And I write it going vertically because then it sticks out in my head and then I won't screw it up. So x values for intervals. So where do the x values, on the increasing part, where do the x values start? That kind of rhymed. They start at 0. And where do they go to? Infinity, yeah. You get scared, right? You're like, ugh. So you can draw the little roller coaster car if that concept helps you, and it's going up forever, right? Because it gets confusing. These graphs gets weird. That's why I added this to what I had planned and then jacked up my whole calendar, but whatever, it's okay. Is there symmetry to this graph? Did it flip over the y-axis or x-axis or go to different? No. No. Any discontinuity? No. Okay, there will be discontinuity. She put it on there because later on there's going to be, but there won't be for a while. So end behavior, you guys do on your own. I'm going to do it up here and you can see if you're right. It's a weird end behavior, just saying. Is there negative infinity on this graph? As x goes to where? What's the first one? Where does it start? Right? As x goes to 0, what are the y values doing? Let's do this one. I think it's easier to understand this one first. As x goes to infinity. So I like doing these little arrows. As x goes this way, what's y doing? It's going up forever, right? Does that make sense? We good on that? Okay, because that's our first little moment of potential confusion. So as f of x goes to infinity as well. Okay, and then the next one, so we already did this way, right? So if you think about those arrows, I think it helps to understand, right? So as we go this way, what are the y values doing? They stop right here though, right? So they stop at 0. So as x goes to 0, right, it stops right here at 0. The y values also stop at 0. So that's weird, right? That's why I wanted to do this section, because you get some funky stuff going on. And to be perfectly honest, your last homework problem, Miss A and I were struggling to understand like what was happening with, right? And she just took way harder math than I've ever taken. And I struggle with it too, but it's okay, right? It's okay to struggle on stuff easy, even as a teacher, right? And you guys got to have faith. We'll always figure it out eventually. Because once she takes over, it's scary to teach pre-calc, right? Like the first year I taught pre-calc, I was freaked out all the time. I'd sit up here and I'd be like sweating. People ask me questions. I'm like, I'm not sure. But what I say is I will always figure it out and let you know, right? So you still have faith in me as a teacher, right? Because the more questions you ask that we can't answer, the less faith you have, right? But we'll always figure it out, right? So she'll be in here by herself eventually, but she'll come ask me a question or ask another math teacher a question and always get you the answer. So just know that'll happen, and it's okay. So when you plug this one in, use the 1/2 in parentheses. And if you've got the old school calculator, you also have to put that 1/5 in parentheses, okay? So we're going to plug that in to y equals. So we're going to go 1/2 x. You sure can. Yep. So you get that weird looking graph? Okay. So it kind of wiggles in the middle there. Is that graph increasing forever? It's hard, right? You're not totally sure. Because it kind of looks asymptotic, right? But it's not. It increases. We'll go over it. Okay. Make sure your graph looks like that, though. Are we good? Anybody need help on that? Good? All right. Let's start filling that sucker out then. Okay. So what's the domain? Oh, we got to do some points. So go second table to find some points. So let's say your graph's at 1100 like mine is, and you're like, I don't want to have to scroll all the way back down. You can always go second window, clear that, and start it at 0, and then go second graph. So we've got 1.5, and we have -1, -0.5. So those are some good points to graph on here. And then we're going to get whatever x value is +8 and -8. So we can figure that out. So -8 is basically 3/4 of the way, right? +8 is going to be the same, just on the positive side. Sometimes when it gets close to the line, my little line gets wobbly, but I don't care. Okay, so draw that. What's domain? That's easy, right? How about range? Are you sure? How can you check to be sure? Look at your table, right? So we're seeing what the y values do. So now I'm going to negative. Are they still going up? So I'll check -6, blah, blah, blah. So, oh yeah, that's bigger, right? Then I can go the other way and double check that way, but you know it's going to be the same thing because this is symmetrical, right? So you can just click through a couple and see. Mine cuts it off there. Yours shows more decimal places on your calculator. So what is the range then? All reals as well. Goes up super slow, that one. Okay. X-intercept, Y-intercept. 0, 0, 0, 0. Right? All this stuff will change. That's why we keep doing it over and over. Is this increasing or decreasing or both? So if I have my little roller coaster car, it's going whoop. It's always going up, right? Does it ever go down? Because we go, intervals are x values, right? So we start on the left and go to the right. So it's always increasing. So decreasing on the right, nope. And then what do the x values do on the increasing interval? Negative infinity to positive, yes. Okay. So they get weird, right? So you got to check the table sometimes. Sometimes you look at it and you'll be so super confused. Sometimes you put it in your graphing calculator wrong, and then you're like, what the hell, right? So all those things will happen. So I will post the solutions. You'll be looking at them. You should be able to finish your homework in class, and I'll show you up here. I may not post them, although I need to for those that are not here. Symmetrical in what way? Origin. Discontinuity? No. End behavior. So as x goes this way, what's y doing? So as x goes to infinity, y is going where? Also infinity. As x goes this way to negative infinity, what's y doing? Negative infinity. Okay? Those arrows really help. So if you get confused on your homework, and I guarantee you will, because it gets funky, this stuff, right? Draw some arrows on your homework. It's okay. Do a different color maybe so you don't get all confused. So as x goes to negative infinity, and again, always do negative infinity first. But sometimes it won't even be negative infinity. We'll have like 0 on there, and it gets weird as we did on the first one. F of x goes to negative infinity. Okay, good. Put number 3 in your calculator. We're going to do all the examples because they're weird in their own unique ways. So this one is a weird graph. You've never seen a graph that looks like this, which is always fun. So let's say, you can do 5 divided by 2. What do you get? 2.5. You could use 2.5 instead of the fraction if you want, right? If it's a terminating decimal, that's fine. I'm just going to put it in normal because, what was it? It was negative 3 in front, right? Yeah, right? Just falls off a cliff, literally. Okay, so it gets weird. So now we got to graph this accurately because I will take points off if you don't. So you need to look at your table. Obviously, we have 0, 0. And then we have 1, negative what? 1, negative 3. You can double check that because it looks on mine like it's negative 2, but it's not. Yeah, it is. I remember from first period. Yay. So 1, negative 3 right there. So you got 0, 0, 1, negative 3. And then we want to see where it goes off the graph. So what are the y values where it goes off? What's the lowest y value on this graph? Negative 8. So you want to look at your table at negative 8 and see what that number is. Negative 8 for y, not x. So, does that make sense? So it says error. So what else can you look at? If you look at your graph, where does it go off in between what two numbers? Like down here is in between what two numbers on the x-axis? 1 and 2. So look there, right? So in between 1 and 2, we can see what the x value is. So it's negative 3 for 1 and negative 16, right? So it's going to go off the graph. And again, if it's weird, like a weird one like this on the test and yours is a little off going off the graph, whatever, right? But if it's obvious to tell where it goes off, either on the positive x side or the negative x side, and you do it weird, we'll take points off. But one like this, we're not going to go crazy on it because it's hard enough anyways. So we get close to positive 2 on the x when it goes off the graph. So it's going to go like that. Okay? So domain, x values start where? Do they go all the way to positive infinity? Yes or no?
Yes.
Yes, they do. The range values, where do the y values start? 0 again, bracket, again, to negative infinity. Good. So the y values are going down forever, right? So you got to think y values, not x values on that. This is the part of it that'll start to hurt your head, right? Because you get confused. Am I looking at x or y values? And it gets weird, right? Is this one, if we think about our little roller coaster car, you don't want to go on this ride. You're going to die, right? You're going to die. It's not good. That's where you're like, ah, and then it plummets to the, yeah.
The green one.
Is it the one that's on the big pole that drops?
The boomerang one.
Oh.
You literally just go backwards and then you drop and then they like go to the top of it and then you have to do something again backwards.
Oh, and that just messes your, oh yeah, that messes with your head. All right, x-intercept, y-intercept, 0, 0, 0, 0. Is it increasing? Nope. Decreasing from where to where? 0 to negative infinity. But, wait. Intervals are what kind of values? So 0 to what? Aw, it's so sad. Infinity. Because it's x values, not y values. It's x values. Right? Because this thing keeps arching out slowly but surely. Right? Keeps going out that way. Right? So that's why it's to positive infinity. Can you guys shut up, please? Symmetrical, yes or no? There's no other side of the graph, so there's no symmetry to be had. Discontinuity, also no. End behavior, it's another weird one. So I think it's easiest to understand positive infinity first. So where are the y values going when x values go that way? Negative infinity. So I'm going to write the bottom one first. So as x goes to positive infinity, f of x goes to what? Negative infinity. Good. All right. So then as x values go this way, where do they stop?
0.
At 0. So as x goes to 0 is up top. That's it. They get weird. As x goes to 0, what do the y values do? Oh, isn't that weird? You're like, is that? Yes, they go to 0. That's right. F of x goes to 0. This is one of the ones where it starts getting weird and you're not totally sure of yourself. But let's say you screwed that up and you wrote negative infinity by accident and you did all the rest of that correct. We'd take like 1/8 of a point off on that problem. Or this problem would be worth like 8 points and we take 1 of the 8 off. Right? So it wouldn't kill your grade if you miss that one. So don't freak out. Or you can freak out. That's always good. So we're going to do negative cube root of x squared. You remember how to get cube root on your calculator? You should. How do you get cube root? Math number what? Math number 4 to get a cube root. So go negative first. Y equals negative math number 4 cube root of x squared, like that. Make sure it looks like that in your calculadora. Math number 4. See, you were talking, so you missed it. My motor mouth group over there. We'll switch them up when you start teaching because they'll irritate the crap out of you. They talk nonstop. So do the girls over there. They also talk nonstop. We'll do a big seating chart change when you start teaching. Break it up. Aww. You could just shut up now, right? And then, no, I'll make the change. They'll get mad at me first. Just shut up when I'm teaching. That's all. That's all you got to do. You got plenty of time to talk in here, right? Just not when I'm talking, that's all. No big deal. You guys have learned. You guys used to be annoying too, but you learned. It's good. I know, you are good now. I agree. I like how your seats always change too. Yeah, first come. It's good. I like it. Okay, we good on that? Everyone got that in there? Anyone need help? Math number 4 to get the cube root. You gonna be okay, Grayson? Phone a friend at your table group if you need to. Okay. So your graph looks like that. Another funky graph you haven't really seen before. Some weird crap happens on these graphs, I'm telling you. Okay? So we need to get some ordered pairs. Do you need help? We'll help you. Are you good? Okay, good. You had such a sad look on your face. I thought you didn't get it.
No, I just forgot the name.
Okay, gotcha. So we're going to go second graph to get some ordered pairs. So we got 0, 0. We have -1, -1, and 1, -1. Okay? So graph those ordered pairs. That'll help. 0, 0, 1, -1. And then we want to get the +8 and -8. So +8, what's the value? Somebody look at your table, tell me. -4. +8, -4 right there. That means this one's also -4 because this one is symmetrical. How is it symmetrical? Yes. Y-axis. Good. Symmetrical Y-axis. You don't have to do them in order, right? Like if you have easy ones, do those first and do the hard ones last. What's the domain? All reals. How about range? You can write it like this too. I don't really care. Isn't that easier to write it like that? Like as long as I know you know what you're talking about, I'm fine with how you write it. Yeah, I just expose you to all the different ways to write it because you may see it in future math classes. Yeah. You're okay. It happens. You're like, wait, nope. Okay, you can write y is less than 0. So they'll write it in set builder notation. It'll look like this. So that straight up and down line means y such that. And then they put those... I hate making those things. It's like I have trouble making them. One way is okay, the other way is not. But this is called set builder notation right here. So they could write it like that. But I'm fine with you just writing that part of it. Because why do you need the y such that? It seems stupid to me. Okay. X-intercept, y-intercept, same thing. 0, 0, 0, 0. It'll change. Don't worry. I know you're worried. On the very next problem, it'll change. Is this increasing, decreasing, or both? Both, right? So if you think about your little roller coaster car, it's going up there, and then roller coaster car, it's going down over here, right? So both increasing. So to increases, again, intervals are x values. So on the left side of this graph, where do the x values start? -infinity. And where do they stop? 0. Squared off or not? Squared off. Bracket. Okay, and then where do the decreasing intervals start? 0. And where do they go to? +infinity. Okay. Discontinuity, nope. As x goes to, the end behavior is easier on this one. As x goes to -infinity, what's f of x doing? Right? And I think the arrows are super helpful, right? As x goes this way, y is going that way, right? So -infinity is correct. Good job. So as x goes to positive, what's y doing? Yep, -infinity again. So sometimes, like, because your head gets in a weird place with these because there's so many different things going on, you make careless errors that you normally wouldn't make. So you guys ever take a really hard math test and then you finish a math test and you go for a walk and then you come back in and you look at the problem again and then you can fix the problem because you get kind of a fresh look at it? Like, that's a good strategy to do because eventually the math will get hard enough for you. Even those of you that got like 98% in here, eventually math will get so hard you can't do it anymore and you need to get help and you need to rely on some of these strategies, right? So you go out, get a breath of fresh air, like splash water on your face, and then you go back and you don't do the problem again, but you just check parts of the problem. So it gives you a unique look at the problem, and then you're more likely to fix your mistakes. Okay? Okay, look at this one. Super fun. So square root of 27 minus x cubed. So we're going to throw that sucker in. So second square root 27 minus x to the third power, like that. Throw that in. Don't be lazy, throw it in. You want to see it in your calculator because it's a weird one. And the graph is not totally accurate on your calculator either because it doesn't show part of the graph. Because it just stops in the middle of nowhere. And you're like, what? Oh, yours is messed up. Hit zoom 6. Different now, right? See?
I don't like that.
Yeah, right? It's a weird one. So zoom 6 in case you've got a weird window. And see how it just kind of hovers above the x-axis? So that should make you doubt, like, what's going on the calculator. Do you need help? It is touching? Okay, that's good. Though the old school calculator works better. Okay, so we need to see if it touches the x-axis or not. So we're going to look at the table of values. And we're going to go, because it looks like it touches at about 3. And it does. So it goes all the way down to 3, 0. Make that dot 3, 0. So we have a dot at 3, 0. And then we're asked what the y-intercept is, so it makes sense to figure out what the y-intercept is. So we look where x is 0, what's y? Look at your table. Somebody tell me. 5.19, so 5.2. So 1, 2, 3, 4, 5.2. About there. Right? And then we need to figure out where it goes off the graph. So if you look at your graph, it goes off like a little after 4. Like, I'm fine with that. After -4, I mean. What? You good? Okay. I didn't mean to do that. So a little after 1, 2, 3. Little after -4, so somewhere like there. So it goes here. And curves, goes off the graph about there. Now domain is weird on this one, right? So what's the left side of the domain?
Infinity, no,
Negative infinity to?
3 closed off.
Good. Right? So parenthesis bracket. So it starts at negative infinity, stops at positive 3. So the range, where do the y values start on this graph? Where do the y values start on this graph? 0. And they go to infinity. So they get weird, man. So what's the x-intercept? 3, 0. Y-intercept was 0, 5.2. That's that point we already got. If we have our little roller coaster car here, it crashed into the x-axis, you still die. So sad. Okay. So is it increasing? No. It's decreasing. So intervals are x values. So where do they start? Negative infinity. And where do they stop? X values, they stop at 3, not 0, right? Squared off, because they stop and it includes 3, because there's a dot at 3. Symmetrical? Not so much. Discontinuity? Still no. End behavior is funky. I have to look at mine to double check it, right? So I think the negative infinity one's the easier one to understand this time. So as it goes this way, negative infinity, what do the y values do? So x is negative, y is positive. So top one is as x goes to negative, y goes to positive. Then if we go the opposite direction, right? So as x goes this way, what are as x goes to what? 3. Good. So as x goes to 3, so as x goes this way, what's y do? See, it says infinity in her notes. I think it should be 0 as well, because they stop at 0, right? As x goes this way, the y values are stopping at the x-axis, which is 0, right? Do we agree? Does that make sense? So as x goes to negative infinity, yeah, they do go up forever. That's what we wrote right here. But then as x goes, so we already went that way, we go this way. As x goes to 3, that's why there's 3 there. What does y do? It's stopping at the x-axis, which is 0, right? It should be 0. And she says infinity.
I think Gina's a liar.
I think, yeah.
Changes her mind.
I know.
Homework, she does it right, and then on the note, she's like, never mind.
Yeah, that's weird. But again, like, so, right, if we're not going to put one like this on your test, right, because if both Miss A and she took way harder math than I've ever taken, right, if both she and I are struggling to be like, but it makes sense to me that it's this, and I think it makes sense to most of you guys that it's that. And this, the last homework problem, is one where you got to think about this. One other concept I want to get you just got to be exposed to so you know it. If we're getting, notice how we rounded right here, right? Because that was 5.19 something or other. If they say I need an exact answer, you need to know how to get an exact answer. So if we want the y-intercept, what do I plug in for x? 0, right? So I'm going to show that work over here. So if we do f of 0, all we do is plug in 0 for x. So we get cube root of 27 minus 0 cubed, which would be the square root of 27. I said cube root by accident. So we got to break apart square roots. What's the biggest factor of 27 you can square root? 9. 9 times what is 27? And I was like writing the square roots right there because you guys get it right more often if you write both of those square roots. What's the square root of 9?
3.
And you can't take the square root of 3, right? It's 1.7, blah, blah, blah. So 3 root 3. That's the other answer choice. This would be 3 root 3 is the exact answer. And the other one we rounded, so it's not exact. Okay? So you just got to be ready for that in case you see it somewhere in the future. Like where the hell they get 3 root 3, that's how they got 3 root 3. Just plugging in 0 for x. Any other questions? Rest of the time you got homework, 1 through 6 all, bus move.